Welcome to a new episode of the Python tutorial series. In our previous episode, we looked at some basic Numpy functions. Today, we're going to take this one step further and learn about some key mathematical operations you can perform using Numpy. As usual, first let's import the Numpy module by writing import numpy as np. Now first, let's write out two arrays. A, which will be numpy.array of, as usual, 1, 2, 3, 4. And then B, which will be numpy.array of 5, 6, 7, 8. Now the first mathematical operation that we're going to look at today is addition. Addition between two arrays works by taking the elements at each index and summing them with the elements in the same indices in the second array. So if we say A plus B, this will give the array 6, 8, 10, 12, which is exactly 1 plus 5, 2 plus 6, 3 plus 7, and 4 plus 8. We can do addition also by calling a separate function which is called add, and we can say numpy add a, b. And as you see, the result is the same. We can do a similar thing with multiplication. If we say A times B, this will give us an array where each element is the product of the elements in corresponding indices. So we have 1 times 5 is 5, 2 times 6 is 12, 3 times 7 is 21, and 4 times 8 is 32. Now subtraction and division work in exactly the same way, so we won't look at them here and we'll move on to new functions. In particular, we have two values which are often used in mathematics, and that is pi and e. Numpy, luckily, provides us with both, so we can say np.pi, and that will give us the value of pi, which is 3.1415, etc. Now, getting the value of e can be slightly trickier, but is still fairly straightforward. All we have to do is type np.exp1. Now exp is the value of e, but in this case we need to specify the power, because technically we could also specify a different power, say 2, and this would give us e squared. If we specified 10, then this would give us e to the power of 10. Now for all of you who love trigonometry, here comes some trigonometric functions. We have np.sine, let's say of pi, and that will obviously give us 0, or a very small value in this case which approximates to 0. We have np.cosine of pi, which obviously is -1. We then have tangent, which is written tan, and that of course is also 0, or a very, very small value. We then have the inverse functions, which are arcsine, arccosine, and arctangent. So if we have np.arccosine of 1, then this will give us obviously the angle 0. If we have numpy.arcsine of 1, that will give us approximately pi over 2, which as we know is 90 degrees. Similarly, if we say numpy.arctan of, for example, 0, that will give us an angle 0. If we say numpy.arctan of 1, that will give us 0.78, which is pi over 4, which is approximately 45 degrees. Now after all those trigonometric functions, I'm sure that you're quite tired, so that's the end of today's episode. Next week, we will learn about some really important Numpy functions, so make sure to subscribe to the channel and turn on notifications so you don't miss out. In the meantime, check out any tutorials you might have missed by clicking on the link in the video description. I look forward to seeing you again next week for a new and exciting tutorial.